Hello, PreAlgebra. In this video, we're talking about repeating, addition, and subtraction. We're looking at it with some variables and with mixing addition and subtraction at the same time. So let's go ahead and dive into it. First things first, when we have 9 plus 9 plus 9, I want to emphasize the difference between rewriting this and simplifying this. Simplifying this is just combining, adding them together, and reaching our answer. So if we were to simplify, we would just say 27. 9 plus 9 plus 9 is 27. If we were to rewrite, then we're taking the 9 plus 9 plus 9, and we're not actually writing it as a single number at all, but what we're doing is we're rewriting it with multiplication. So 3 times 9, or 9 times 3. Either of those are correct. And why is it 3 times 9? Well, because we're repeatedly adding by 9. So repeated addition is multiplication, like we talked about that very first week. So 3 times 9, or 9 times 3, does equal 27, but rewriting as multiplication is different than simplification. So let's take that and apply it to some variables here. Let's go ahead and take it and apply it to x plus x plus x. Here, we can't simplify it to a single number. And we would not call it rewriting as multiplication. So up here with the 9s, I had to specify because this is what we call simpler, but it is not simplified completely. We have to continue our multiplication and combining our numbers as much as we can until we get down to the simplest form, which in this case is 27. That's because there's nothing else we can do. It's simplest because it's the minimum that we'd have to look at. It's just 27 rather than 3 times 9, or even more to look at, 9 plus 9 plus 9. With the 3x's, we would just call it simplifying. And to simplify this, since we can't figure out what number it is to simplify it to a number, the only way to simplify it is as 3 times x. And like we talked about before, multiplication can be written without a symbol, so just 3x. And that is completely simplified. It is also rewriting it as multiplication, but here that's the exact same thing. Well, I'm not saying anything different because that is as simplified as it gets. So let's take that a step further. Let's do 3y plus y. So looking at the example up above with x plus x plus x, it is 3x because we are adding 3x's. Addition, when it's repeated, is multiplication. 3 times x is x plus x plus x. We're counting the number of x's out of there that are being added together. In this example with the y's, 3y plus y, well, the question is, how many y's are there? And so 3y plus y is 3 with an additional, so we have 4 y's. But saying we have 4 y's is in of itself how we describe multiplication. 4 y's added together is 4 times y. So we have 3, we have 1 more, so the total is 4. Let's take that to this example. 7z plus 3z. Once again, we have 7 z's that are being repeatedly added together. That's why it's 7 times z. And we have 3 more z's being added together. So how many z's do we have total? 7 plus 3. We have ourselves 10 z's that are all being repeatedly added together. And so one last step of application here. we have 4w plus 2w plus 2y. Now we want to combine our like terms here, and when I say like terms, I mean we want to combine the things that are similar. So if I expand this, if I rewrite it without any of the numbers because I'm just showing that repeated addition, well, let's go ahead and use green for the first part here. The 4w is just 1 plus 2 plus 3 plus 4. 4 w's. In pink, we have 2 more w's. Plus 1 plus 2. Then we have ourselves the y's, and I'll use the red one for that. Plus y plus y. So if we wanted to simplify this, we're wanting to combine however many w's we have. And in this case, we have 4 green ones and 2 pink ones. 4 plus 2 is 6. So we have 6 w's. And then we want to combine the number of y's we have. W's and y's aren't the same thing. It's like talking about apples and oranges, or, boats and camels. They're not the same, so we would not combine them together. And so 6 w's are added to our 2 y's, and that's as simple as it gets. Because 6 w's and 2 y's aren't the same thing, we can't make it 8 because they're not the same. We don't actually have 8 of one thing. We have 6 of one thing and 2 of another. So let's take this and now apply a little bit to the subtraction piece. And so we added 9 and 9 and 9 earlier in this. Let's do minus 9, minus 9, minus 9. Well, repeatedly adding gives us multiplication. Repeatedly subtracting also gives us multiplication, but with a negative number. So minus 9, minus 9, minus 9, well, that's going left 9, and left 9 more. That's ultimately going to be negative 27 when we simplify it. But when we rewrite it, and so yeah, this is simplified. But when we rewrite, the negative 9 minus 9 minus 9 is the same thing as 3 times negative 9. Now notice I used parentheses here, and that's because it's easier to see the negative 9 with parentheses being multiplied by 3. Just visually, it's easier. Visually, it's nicer to read. We absolutely can write 3 times negative 9. But if you have messy handwriting, or if you're someone like me who likes to write quickly, then what ends up happening is that the negatives look more like dots. And then you're not able to tell what's a negative versus what's not a negative. And writing the parentheses takes care of some of that. It implicitly shows that there's multiplication because there's no sign between the 3 and the parenthesis, and that the symbol next to the 9 has to be a negative because by the process of elimination, it's not multiplication. We already included that. And so that is the same thing as negative 9 times 3. I'm sure you're asking, why isn't the 9 in parentheses? Well, it's just tradition that we put the second number in parentheses, but it doesn't have to be, because this representation of multiplication works like this, where they're both in parentheses, or where the first one's in parentheses. I'll tell you that this last example I gave here, you don't hardly ever see from anyone who does mathematics. It's accurate, it works, but it's not very common because people prefer to put the second number in parentheses. As to why, I'm sure that there's an old white guy out there who invented it, who said that's the way we should do it, so that's the way we should do it. If only there was more people who had been involved with math so far in our history that really could make a difference with that. Now, with that being said, we looked at all those different ways to write 9 minus 9 minus 9, and all those are just rewriting it as multiplication. let's go ahead and look at this example. It looks pretty much the same, except the only difference is our very first 9 does not have a negative. So here's where we have to be careful, because repeating addition and repeating subtraction is multiplication. But in this case, we're not repeatedly adding. And we're not repeatedly subtracting. What we're doing is we're adding by 1. So this is a positive 9. And these are negative 9s. So what we actually have here is 9 minus 9 minus 9. But what happens when you have 9 minus 9? Well, when you subtract anything by itself, you get 0. And so we have to simplify our addition and subtractions before we can look for any repetition. That way there's no mistakes and we're not making any assumptions that aren't actually true. So when we simplify this, we just have the one negative 9 we're dealing with. 9 minus 9 is 0. Minus 9 is negative 9. And that also works and is true and applies to all the examples we did with variables. And so let's go ahead and take the example of the 3 x's, but let's make a couple of them negative. Let's do x plus x minus x. Well, we don't have 3 x's that are being added together. We have 3 x's, but one of them's being subtracted, and so we have an x minus x. Anything subtracted from itself is 0, so we only have the 1x that we're working with. Let's do 3y minus y. Well, here we don't have 4 y's anymore because the 4 came from adding by y, repeatedly adding by y. The 3 is positive, so we're repeatedly adding 3 y's here. So we have 1 plus 2 plus 3, but our y in black is being subtracted. And so y minus y is 0. 3 minus 1 is 2 y's. Where did I get the 3 minus 1? Well, I have the 3 red y's are being added together, so that's a positive 3 minus the 1 y in black gives us 2 y's left over. And we don't have to expand it to see that. Up above, we have the 3 minus the 1 gives us to 2y. And why is that a 1? Well, because there's no number written. So there's only 1 y there. You could write the number 1 in there. And that makes just as much sense as not having it there, because there's still just the 1 y. So let's go ahead and take this example and do the negative 3y plus y. Well, here, negative 3y plus y, we have lost 3 y's. We're subtracting 3 y's. So it is minus y, minus y, minus y. And we're adding by 1. So when we go to combine this, when we look at how many y's we're actually working with, a negative is subtraction. Y minus y. Or if we want to read it in order, it's negative y plus y. That's the same thing as just subtracting by itself. That gives us 0. So we're only left with the 1, 2 y's that we're working with that are being subtracted. So we're subtracting 2 y's. Negative 2 times y. So that should give you the leg up and the start that you need to look at the repeated addition and subtraction problems. Don't hesitate to email me if you have any questions, and I look forward to working with you this week.